notes. We're going to continue 4.4 logarithms. Side note, last time I couldn't show up to class. I posted a video about log graphing. I'm not going to make you graph logs. So just watch the video, know how it kind of looks like. Looks kind of like this. That's all you need to know. You will not be forced to graph a log. At least I have not want to teach you how to graph a log, really. But it kind of looks like that. Okay. So let's talk about two things. What we're going to do today is we're going to practice solving logs with and without a calculator. On the upcoming test for this section, there will be a section with calculator and there's a section without calculator. So you need to know both. Okay. So you definitely need to be able to do it without a calculator. Let's talk about the first one, the common log. Log base 10 is the same as log blank. So if you see a log with no little b or no little base, you assume it's the number 10. The same way in a square root, you assume it's a number 2. The same way, if a normal x, the exponent is a 1, you assume it's multiplied by 1. This one, you assume it's a 10. So if there's ever a situation where they show you just log, no little number in bottom, it's just 10. The second one is a special type of number, E, and E is special for its reasons that I won't explain now. Maybe we'll explain later. Excuse me. But this is called the natural log. And it's LN, log natural. It's, or what, however you say it in France, because it's a French guy who made it. But is the natural log, so LN, which means it's log with a little e on the bottom, okay? Now, just in case you forgot what logs are, let me write this little factoid for you. The base to some exponent gives you the result is the same as that exponent equaling the log of said base to that result. These two things are the same thing. Logs and exponents are inverses from each other. So it's very important to know that the base of the exponent and the base of the log are opposites. We covered this last time. I just wanted to tell you now, just to refresh ourselves. All right. Now, the first thing we're going to practice is the calculator versions, which requires us to do the change of base formula. So the change of base formula is very straightforward. When you have the base b and whatever's inside the log normally, so this is like a normal size number, let's say a, you convert it to log of the normal divided by the log of the base. It's a very simple formula. Basically, you have log base b of a, you change it to log of A over log of B. That's all. So the base goes to the bottom. Base goes to the bottom. That's how you want to remember it. All right. Anyone could unmute themselves. Any questions on so far on this stuff? Anyone still copying, or can I go right to the next page? If you're still copying, just tell me so I can give it a minute.
I'm done.
Thank you, Mark. All right. So let's go to the next page. Not much to copy on that. Let's talk about two examples here. And I have my, oh no, I don't want you to get small. But I have my TI-80 right here. I'll show you how to do it on TI-80. If you have a TI-83, it should still look the same. You don't have to worry about that. Okay. So let's look at this first. Log of 85, okay? So log of 85. Now what's nice is that your calculator has a log button. And that log button is 1, 2, 3, 4 above the on button. So if I can annotate, it's over here.
Mr. Tobal, can you record the class, like the class
Already
thing?
ahead of you. Already ahead of you. It's already
All right,
recorded.
perfect.
So you have the log button here in the calculator. So you literally just click it. Then you type in your number, 85, and you click enter. For these situations, I would like you to do, let's go 2 decimal points. I'm going to do the type in. There we go. Let's do 2 decimal points. So 1.93. So log of 85 is 1.93. What does that actually mean? What that means, because if we don't see a log, it's a little 10. What that technically means is that 85 equals 10 to the power of 1.93. About, because it's an estimate, but it means that 10 to the power of 1.93 equals 85. But you don't have to point that out in the blue. That's just a little side fact to connect back to the exponents. Just want you to know they're connected. Now the ln button is right underneath the log button. The ln button is right underneath the log button. If you're in a situation where you're forced to use your phone calculator, if you turn it sideways, there should be those buttons in the scientific form. That toss. So the ln button, we just click the ln button in order to get it. Oh, wait, clear. Oh, there. Okay. Anyway, ln of 22. So you click ln of 22, set enter. This is 3.09. Now we're going to do one more problem. It's not here, so I have to write it in. Log base 3, let's say 15. Yes, Sheva, you know, last time I said you have to ask every time. That's dumb of me. I'll just post it regardless. So you don't have to ask every time. I was being arrogant. So my bad on that. So I'll post the recordings every time, unless I forget to record. Sometimes Zoom corrupts it and then the recording's lost and it can't be converted. So unless that happens, I'll post the recording of the class every time. I know that helps also with studying for the test, so why not post it for you guys on the behavior. So again, I apologize, but last time I said, ask me. Nah, you don't really have to ask me. I'll just do it. All right. Log base 3, 15. Now, here's the problem. You only have two buttons over here, log and ln. That's not very useful for us. So what we need to do is change this into buttons we do have. So we need to change this to common logs. So log base 3, 15 will become log 15. So the normal number goes on top, divided by log 3. This 3 becomes a normal size 3. It's no more the base 3. Okay, so log 15 divided by log 3. In the calculator, you click log 15, close the parenthesis. Don't forget to close the parenthesis or you're going to get the wrong answer. Divided by the log button again, 3. Click enter. 2.46 is your answer. And just a reminder, what does that actually mean? That means if I did 3 to the 2.46 power, I should get about 15. And I'll just show that with the calculator since I have it. 3 to the power of 2.46. It's not going to be 15 exact because this is an estimate. 14.9 would round to 15, yeah. Okay. Happily take any questions on that situation.
Mr. Tolwell,
Yeah, I'm here. What's up?
what is this like in thing?
The LN?
Oh yeah, my bad. I thought it said I.
No
Yeah,
problem.
what is that LN?
LN is a natural log. It's in the previous page. Check out the recording a little later, or stay a little after class. I'm happy to explain. But I don't want to explain it to be fair to the people. So.
Okay.
It's just a different log.
Okay.
All right. All right. Now we're going to do it by hand. All right. Now, most of these are going to be mental math-esque. All right. I'm going to make these bigger. Or actually, I don't really need the calculator anymore, so I can just do it like this. A reminder, if you see just a log, that's the same as log base 10. And if you see a ln, that's the same as log base e. All right. So let's talk about the first one. E to the power of ln 9. Another way you could see this is e to the log base e to a normal 9. So there's two ways to look at it. Now, here is the special rule about logs. If you have a log that where the base is the same as the normal number, and you have some exponent on top, let's say x, you can cancel this out, the base and the base of the exponent and the base of the log, and what you will be left with is x. So that is actually an important rule. So I'll do it without the little red lines. So log, the base of the log and the base of the exponent being together means you could cancel out and you would be just left with x. So base of a log and the base of the exponent being the same number.
So if it's like log base x, then the answer is just x.
Absolutely, as long as the bases are the same. And then we're going to have basically the reverse situation. If you have some base of the exponent and it goes to the power of log base of the same value to a normal x, you can cross that out and you're also just left with x. So if you have a base of a log with an exponent or base of an exponent with a log, and those bases are the same, it's very important, are the same, you're able to cancel them out. So why is that significant? Well, let's look at the problem A. We have e log base e to the 9, or like log base e9, technically how you say it. E and log base e are the same thing. Because they're the same thing, I can cross that out. And all I'm left with is a normal 9, which means my answer for this is just a 9. And if you type this into the calculator, you would just get a 9. This is a non-calculator question. So you won't have a calculator on this type of question. So you need to know this rule, but you could confirm it on calculator if you wish. Okay. Next one, log base 3, 3x. You know what's really nice? 3 base, double base, double out. You're just left with x. Again, you have the base of the log and the base of the exponent being the same value. You can cross them out. All right. Let's talk about this last piece here. Now, here's my issue, or here's where it becomes an actual problem. We have log base 3 and log base 27, or log base 3 and an exponent base 27. Now, what kind of sucks is that they're not the same number. Now, what would be really nice, though, if they were the same number. So does anyone have any idea, is there any relationship between 3 and 27 that maybe we could help change it to look the same? Anyone wants to, I'll give like a half a minute to look at it. What do we know about 3 and 27? If you have an idea, you could just throw it out there.
You can do 9 times 3 or 3 to the power of something. You know what?
Okay. Now, that's a wonderful suggestion, which is actually the correct suggestion. Now, 3 times something gives you 27. That's nice to know, but we need it to be in terms of like exponent stuff. So we need to see if 3 to some power gives you 27. We know 3 to the 1 power should be 3. 3 to the second power, 3 times 3 is 9. 3 to the third power equals 3 times 3 times 3, 27. Wait a second. 3 to the third power equals 27. And if you remember from geometry, we had a rule or the law of substitution, which means if they're equal to each other, I can swap one for the other. So what should I swap 27 with? should be pretty clear. Probably the thing I boxed. I'm going to swap this 27 to become 3 to the third power. So this 27 became 3 to the third power. Now, slight little fact, you had an X here before. You don't want to forget them. So you're going to put a little X here. All right. So it's going to be, I should technically say, you're 3 to the third to the power of X, or you would just multiply the exponents. So it's technically 3 times X. Okay. I should technically say it like that. It's 3 times X. Now, doesn't really matter. You could just rewrite that as 3X. 3 log 3. Yeah. Base 3x. Okay. Now, very important. The 3's that are going to get canceled out is only in base. The exponent will never be canceled out in this situation. So only this 3 and this 3 will cancel out. So this 3 and this 3 will only cancel out. The 3x on top does not get canceled out. Even though it happens to be the same exact number, it will not get canceled out. Which means what you're left with is just 3x. Okay. I'm happy to take any questions on this. The key part, though, is you have to figure out what could I change the number here into so it matches the number in my base of the log. What number can I change it into so they match, essentially? Because if they match, then you could cross them out. Let's copy the one from the previous page. Next page. Okay, that's what I wanted to cover today. So I'm going to give you an exit ticket to make sure you actually learn something. And if you don't get the exit ticket right, that's okay. I will go over it. So this is your exit ticket. Log base 2, 32. I forgot the little x here to the x. Log base 2, 32 to the x power. Send me privately what the answer is if you think you can get it. If not, just wait out about a minute, maybe a minute and a half, and then I'll go over it. Aliana, you got the right answer. You're free to go. Have a wonderful day, okay?
Thank you.
No problem. All right, good to hear, Carmela. And you're good. You got the right answer. You have a wonderful day, Carmela.
I think
Nate, my man, good job. You're free to go.
Have a good day.
You too, man. Alyssa, solid work. You're free to go. Have a wonderful day.
Mr. Tolbo, I don't know how to do it.
All right. Does everyone want me to do it, or anyone wants like 30 seconds more? If not, I'll just go.
I'm a bit stuck as well.
Okay. All right, let's take a crack at it. All right. So Haley, what is my goal here? Like, what do I have to do, or what do I have to change? Like, what am I trying to do? Any idea, Haley?
I don't know.
Okay, fair enough. What about you, Nahum? Any idea what I'm trying to do here?
Not really.
Okay, that's fine. That's literally, I get paid to teach you that. I need these two to be the same. Mariah, if they're the same, what does that allow me to do?
If they're the same, what?
If this base was the same as this base, what would I be able to do?
I have no clue.
Okay. If they were the same, we could cross them out. Kind of like here, we have log base 3, 3. Since they were the same, we could cross them out. So I have to see if there's a way, a possible way, to change 32 to be the same as 2. So what I'm going to do is use powers to my advantage. Now, like I know it because I teach math for a living, but let's say you don't, and you don't have a calculator because it's a non-calculator section, you're going to have to do a little bit of power work to see what power of 32 will equal 2. So you go 2 to the first, that gives you 2. That's not it. 2 to the second, 2 times 2, 4. That's not it. 2 to the third, 8. That's not it. 2 to the fourth. I wrote 3 for some reason. 2 to the fourth, 16. That ain't it. 2 to the fifth, 32. Wait a second. That's what I was looking for. So if it is 32, I can replace it with 32. So I have log base 2. This 32 turns into 2 to the 5th power, to the x. So don't forget that little x right there. Now, Sheva, because I have a log base 2 and an
Mr.
exponent
Tobal?
base. What's up, Mariah?
I have to go right now, but I'm gonna look at the recording and email you, okay?
Okay, no problem.
Thank you
So
so much.
No problem. Sheva, since the log base 2 and the base is 2 here, what am I allowed to do? Sheva, you there? Haley, what about you tell me? What can I do with these 2's?
I'm not sure, but how did you get the 5?
Oh, I got the 5 because 2 to the 5th power equals 32. Or 2 times 2 times 2 times 2 times 2 is to the 32. So that's how I got that 5 right here, right? So because this 2 and this 2 is the same, Nahum, what am I allowed to do?
Multiply the 5 and the 2. Like the logs.
No,
No.
no, not multiply it. I'm allowed to cross them out.
Can you cancel it
Cross
out?
them out. Okay.
Yeah, cancel it out. Which means, who am I left with? Simply 5x. So remember, you have to think your goal is to change the number to match the base. You're changing 32 to match the 2, okay? All right. I ran out of time, guys. So right here for your attendance. All right. I want to wish you a great day. Check out the recording if you need to see it again, or send me an email. I'll make even note if you need me to make new notes for you or re-record it. I'm happy to do that too.